Today we are talking about section 8.7, which is talking about function notation. Now, the good news about today is we aren't doing anything new. It's all things that we've already talked about, but it's going to look different, and they're going to write it a different way. So let's look here at the little blurb that I wrote down. When you use an equation to represent a function, it is often convenient to give the function a name, such as f or g, so function f, function g. For instance, the function y equals x plus 2, we can rewrite it in function notation, and it will say f of x, that's how you would say that, f parentheses x equals x plus 2. F is the name of the function, and it just means that f of x replaces y, and it tells me the value of function function f at whatever this value of x is. Sounds kind of confusing, but I'm telling you, it's already stuff that we've done. So we're going to squeeze 4 examples in this first spot here, because there's just a lot of things that you can do with this. Now, if we look at the top, I have 2 functions. I have function f, or f of x, and it is equal to 10x minus 8. And then I have function g, which is equal to 2x plus 1. Okay, so we want to find the indicated value. So let's see what this is meaning. Okay, I want to find f of x. So I want to find the value of function f at x when x equals negative 2. So I want to find the value of function f when x is negative 2. Now, notice, since I'm talking about function f, I'm going to look at this first one here. And I know that f of x is equal to 10x minus 8. So I want to find f of x. I want to know what that left-hand side of the equation is. So it tells me that x is negative 2. So I'm going to plug negative 2 in for x. So I have 10 times negative 2 minus 8. So I get negative 20 minus 8. So f of x is equal to negative 28. So they gave me what the value of x was. I just needed to make sure that I picked the correct function and plug it in. Okay, well, what if we want to go the opposite way? And this time I want to find out what x is when g of x equals negative 13. Okay, this time, look, I'm talking about g of x, so I need to use this second equation here. So let's rewrite this equation. I know g of x equals 2x plus 1. Okay, now this time I'm looking for x, and I know what g of x is. G of x equals 13. So I'm going to rewrite my equation, but instead of g of x, I'm going to write negative 13. And then the rest of the equation just stays the same. Well, look, it's just a 2-step equation. Solve for x, I would subtract 1 from both sides. Negative 14 equals 2x. Divide by 2, so x equals negative 7. So really just plug in values in for x or for g of x. Okay, another way that they'll write it, I want to know what g of negative 12 is. Okay, now first off, I'm looking at function g, and just to remind ourselves, g of x equals 2x plus 1, just copying it down from above. Now, they want to know what g of negative 12 is. I want to know what function g is when x is negative 12. It's almost exactly like the first equation, except it's just in a condensed form. The value of g of negative 12 is the value of g when x is negative 12. So to find g of negative 12, I'm going to plug negative 12 in for x. And when you solve that, we get negative 24 plus 1. So g of negative 12 is negative 23. Okay, and last one. Let's try f of negative 3 plus g of 4. Okay, so this time I really just have 2 functions I need to find the value of. I need to find out what f of negative 3 is using the same steps we did in the last example. I need to find out what g of 4 is. So I want to know what the value of f is when x is negative 3. And then I want to know what the value of g is when x is 4. So let's look at function f, and I'm finding f of negative 3. So function f was 10x minus 8. So I want to know the value of function f when x is negative 3. So instead of x, I'm going to plug in negative 3. So I get negative 30 minus 8. So f of negative 3 is negative 38. Okay, now then I need to find g of 4. I want to know the value of g when x is 4. Okay, well g is 2x plus 1, so I'm going to plug 4 in for x, and you should get g of 4 equals 9. So what I'm really doing is taking negative 38 plus 9, and you should get a negative 29. Okay, now I know that was kind of a lot in a little short bloop, so just keep this handy whenever you're working on your homework, so you know what to do when it asks you certain things. Okay, so finding values of functions, we also can graph a function. So let's just look at an example. I want to graph the function f of x equals 2x minus 4. Now maybe you remember at the very, very beginning I told you that f of x, this name of this function, is really just replacing y. So the first thing we can do is instead of writing it f of x, I can write y equals 2x minus 4. It's the same thing, just looks different. Now if I have y equals 2x minus 4 and I want to graph this, it's already in y equals, so I can go ahead and identify my slope, and I can identify my y-intercept. My slope is 2. My y-intercept is negative 4. To graph this line, I'm going to first start by plotting my y-intercept at negative 4. Then to plot my second point, I'm going to use my slope. And my slope tells me to rise 2, run 1. So from my y-intercept, I'm going to rise 2, run 1. I have my 2 points. I've graphed my function. Okay, I want you guys to do this one, and you'll do this exactly the same way we did that last one. This time we're talking about function h. So h of x equals negative 3/2 x plus 3. So take a minute, go ahead and graph that equation, see what you get. Alright, your function should look similar to mine that you see there. Okay, and last one, this is what we just got done doing yesterday. We're going to do 3 of these. I want to write a linear function that satisfies the given conditions. So writing a function, or writing the equation of a line, but since it says write a linear function, the only big change is that instead of saying y equals mx plus b, we're going to say f of x equals this, or g of x, or whatever my function's name is. And we'll get to that whenever we get to that part. So my given conditions, I'm going to say f of 0 equals 1, and f of 2 equals 9. Okay, now it looks just a little different, but what I actually have is I have 2 points. Now, remember function notation, what it means? This means for function f, when x is 0, y is 1, right? For function f, when x is 0, I get 1. When x is 0, I get out 1. The number that's in the parentheses next to the name of my function, that's your value of x. And remember, I could rewrite this and say y. So y equals 1, x is 0. My second point, this means for function f, when x is 2, y is 9. So my second point would be 2, 9. Okay, well now I have 2 points. this is the exact same thing we've done the last 2 days. I need my slope and I need my y-intercept. So to find the slope, we're looking for my change in y over my change in x, and I should get 4. So I have a slope of 4. Now I need to find my y-intercept. So we're going to use our generic equation of the line. Pick one of your points. I'm going to use that first one. Instead of y, I'm going to plug in 1. My slope is 4. My x is 0. And I'm solving for b. So you should end up with b equals 1. Now, yesterday, we would say that the equation of my line is y equals 4x plus 1. But I want a linear function. The only thing you need to do different, since I'm talking about function f, I'm going to say f of x equals 4x plus 1. We're just going to replace y with the name of my function. Okay, let's do one more together. Let's say f of 0 equals negative 7 and f of 6 equals 5. Now remember, this function notation means that for function f, when x is 0, y is negative 7. So I have a point 0, negative 7. And also for function f, when x is 6, y is 5. So I have the point 6, 5. Okay, I have my 2 points, so let's find the slope. So we're going to find the change in y over the change in x. So negative 12 over negative 6 gives me a positive 6. So I have my slope of 6. To find my y-intercept, I'm going to pick one of my points. Let's just use that first one. We'll plug 0 in for x. Negative 7 in for y. We'll plug in 6 for my slope, and we're going to solve for b. So I end up with negative 7 equals b. So if I wanted to write an equation of this line, I would say y equals 6x minus 7, but we want to write a linear function. So instead, I'm talking about function f, so f of x equals 6x minus 7. Okay, I want you guys to try this last one on your own. This time we're talking about function r. R of negative 7 equals 3, and r of 0 equals 3. Okay, so I want you guys to pause the video, try this one on your own. Okay, the linear function should look like r of x equals 3. If you have r of x equals 0x plus 3, that's fine, but we kind of want to get in the habit of if it's 0x, let's just not include it.